Okay, so my last video got interrupted. I don't know why, technical difficulties, so now you get 4 videos. Let's go ahead and finish this last problem. So the idea is we're going to move this function, this rational fraction, over to the left so that we only get one fraction greater than 0, and then rather than finding where the two graphs intersect, we just need to find where one function is greater than 0. So that is the plan. Let me erase this. So let's go ahead and do that. 8 over x minus 3 minus 6 over x minus 1 is greater than 0. We need to find a common denominator. Our common denominator needs to be x minus 3, x minus 1. This is going back to your adding and subtracting rational functions from secondary 3. We haven't done this a ton this year, so if you're confused, then you can look online for adding rational functions or come in for some help. So I need to multiply this first fraction by x minus 1 so that the denominator matches our new denominator. Multiply the second one by x minus 3 so that this denominator matches the new denominator. Now we're going to go ahead and distribute. So we'll get 8x minus 8. I'm going to go ahead and move this negative sign up by the 6 so I don't forget about it. And this is negative 6x plus 18. Combine like terms. 8x minus 6x is 2x. Minus 8 plus 18 is plus 10 over x minus 3, x minus 1. So that's the algebra part of this. We now want to look at where this left side function is greater than or equal to 0. So let's go ahead and graph it. Okay, vertical asymptotes at x equals 3 and x equals 1. Draw those in. This is degree 1 over degree 2. That's proper, so we have a horizontal asymptote at y equals 0. Next, let's find some intercepts. Our x-intercept is when y is 0. So the shortcut is you set 0 equal to your numerator, subtract 10, divide by 2, and x is equal to negative 5. So let's go ahead and draw that in. Now, it is okay if a graph crosses a horizontal asymptote, so that point is fine. Let's go ahead and find a y-intercept. That's when x is 0. So y is going to be 2 times 0, which is 0, plus 10, divided by 0 minus 3 times 0 minus 1. So we get 10/3 is our y-intercept, which is not approximate, but actually equal to 3 1/3. So we cross the y-axis at 3 1/3. Okay, now our graph must come down from the left side of this asymptote, and then it's going to continue down and cross through this point, but it still has to approach the horizontal asymptote. We could test more points to see what happens, but this is likely scooping down and then going back up to approach that asymptote as we go towards negative infinity. Now, we don't have any more x-intercepts, so we can use our multiplicity to figure out what is happening next. So at our intercept of x minus 1, not intercept, excuse me, our asymptote at the factor x minus 1, so our asymptote at x equals 1. Since we have a power of 1, we're going to switch signs. So that means if along this asymptote here, we are headed up in this direction, we're now going to switch signs and come from below in this direction. since there is no x-intercept here, this graph cannot cross, otherwise we would have had an intercept. So instead, what we have is some kind of parabolic shape that must go back down. Now this asymptote here at x is 3 is a multiplicity of 1, so that means the sign is going to change again. So if this is going down, then we're going to come up on the left from the up position. There's no other x-intercept, so that creeches out towards the right. I think I just said creeches. I don't know what that means. Creeps out towards the right, reaches out towards the right. Okay. All right, let's go ahead and answer this problem. So remember, we're solving an inequality. So our inequality was when is one function greater than the other. We wrote that to say when is our function greater than 0. Our function is greater than 0 here, and our function is greater than 0 here. So write that in interval notation. We start at this point, parentheses, -5. We end at this asymptote here, 1, union. We pick up again at this asymptote here, 3, off to infinity. Done.